Unity gives us several built-in methods to work with. These methods make it very easy to apply some code and get our objects to behave in the ways we want. In order to look at some of these built-in methods, I'm going to first create a script. We saw how to do this in a previous section. I'm just going to right-click in the project view and go Create, and this time I'm going to choose a C# script. I'm going to name my script something like Default Method Script. Now, in order for scripts to actually run in Unity, they need to be on a game object. So I'm going to go ahead and create a new game object. I'm going to go to the hierarchy and I'm going to select Create 3D Cube. To apply my script to this cube, I'm simply going to drag the script from the project view onto the cube in the inspector. And we can see it's now a component of that cube. I'll double click it so we can edit the script inside MonoDevelop. So as we saw in a previous section, scripts made by Unity have this default format applied to them. I'm going to go ahead and modify this format a little bit so it's more in keeping with our project and our standards. Now again, as we saw before, there are two methods already existing in this script created for us by Unity. The first is on line 7, the method name is start, and the second is on line 13, the method name is update. These two methods are very useful methods, which is why they come already added to our scripts. The start method is called one time whenever an object first starts up. It's a great place to initialize any data or to talk to other scripts or to perform any startup code. So let's examine how this works. I'm going to go ahead and add a line of code to our start method that's going to make it write something to the console window or the log when this object starts up. Now we can see on line 9, the code debug.log object starting is going to write the words object starting to our console window when the object first starts up. I'm going to go ahead and save the script, go back to Unity, and let's take a look at it. If you're using the default layout, the console window can be found right next to the project window. If you're not using the default layout or you can't find your console window, you can always go to Window, Console to open it up. Now I'm going to go ahead and hit play, and we're going to see an output to the console window. So as we can see, we see object starting written in the console, and if I click on it, I can see a little bit more about it. I can see that it was called from the default method script and the start method. Specifically, line 9. So now let's look at the update method, which is going to get called a little bit differently. Like the start method, the update method will be called for us automatically. Unlike the start method, the update method is not called only one time. It's called over and over again. It's actually called once for every update frame, and it's where we do things that we need to continually check, like look for user input, or move an object, or determine health, or anything like that. Things that are relevant to the ongoing gameplay. So I'm going to add a line of code here, and we're going to see how this behaves. Now we can see, just like the start method, the update method is going to write object updating to the console window. Let's see how it behaves. Okay, so I only let the window run for a very short time, but we can see that we have 70 messages. 69 of those messages will be object updating, with the very first message again being object starting. So we can see we update very fast. If at any point you want to clear out the console window, you can simply click clear, and that'll get rid of all the messages currently there. Let's go back to our script and look at some other methods that are built in, but not there by default. So we have this start and update method, but there's a specific timing to scripts. There are methods that will run before start, and there are methods that can run after update, and there are methods that will only run in certain situations. Let's take a look at a method right now called awake. This method gets called before start. It's actually the first method that's called on any script. The awake method gets called when the game first starts up, or when an object first exists. Another way to look at awake is that it's the first method called when a scene starts, before anything else happens. Awake is in fact even called if a game object is disabled, because awake is called before an object is enabled or disabled. So if you need code to happen, the very first thing in a script, you put it inside the awake method. I don't really want the console window filled with all of the log statements from my update method, so I'm going to add something called a comment. I mentioned comments previously. Comments are basically lines of text that are not meant for the compiler or the computer, they're meant for the people around us. If we want to quickly disable a line of code, we simply need to turn it into a comment. To turn something into a comment, we just apply 2 forward slashes. If we want to comment out an entire block of code, we can use a different method. To do an entire block of code, we can do forward slash asterisks, and then to uncomment, asterisk forward slash. We don't really need a block comment right now though, so I'm just going to apply a line comment. Now back in Unity, if I hit play, I can see object waking and then object starting. Another great built-in method actually runs between awake and start, and it's called onEnable. You might be wondering, if you have awake and you have start, why do you need onEnable? And the answer is, awake is called before an object is enabled or disabled. It's called right when the scene starts. Start is called one time when an object first starts up. And onEnable is called right before start, right after awake, if the object is enabled. If it's not enabled, this method isn't called. Furthermore, if you have an object and you disable it and then re-enable it, start isn't run again, nor is awake, but onEnable is. So if you need some code that runs every time an object becomes enabled, you can put it inside onEnable. So let's see this in action. So now we can see in the log, object waking, object enabled, object starting. Now I'm going to click on my cube here, and I'm going to disable it, and I'm going to re-enable it. And now I see object enabled. Again, the onEnable method is called whenever an object is enabled, and so we can make it run code more than one time. There are a few more methods that are important to know because we're going to use them a lot here inside this courseware and the accompanying project. We've seen update, and we know how update works, but there's another type of update as well. That update is called fixed update. Fixed update is called just like regular update. It's called over and over again. However, fixed update isn't run as fast as it can be. It's run at a very specific time interval. That time interval is by default every 2 milliseconds, or 50 times a second. This allows fixed update to keep completely in sync with Unity's physics system. Therefore, fixed update is where we do all of our physics stuff. That's where we might apply forces, that's where we might detect collisions, that's where we might do anything that requires physical movement. I'm not going to add a line of code to fixed update because I'm pretty sure you understand. It's just going to loop, but it's going to loop at a very specific interval. Another method to look at is not a method that's called automatically by Unity at any particular interval. It's not like awake or start or update or even fixed update where Unity is calling these automatically at a specific time. Instead, this method, called onMouseDown, is only called when a specific event happens, and that event is whenever the user clicks on this object. If this method exists on a script that is attached to an object, and that object has a collider, and then the user clicks on it or taps the screen on a mobile device or a device with a touchscreen, this method will be called, and we'll see this message written in the console. So now that I'm running my scene, I'm simply going to find my cube and click on it, and I will see object clicked. I can do this as many times as I'd like. The last method we're going to look at is called the reset method. The reset method is very useful for setting up the default properties of a script. Now we haven't really gotten to variables yet or anything like that, but let's take a look just really quick at what exactly the reset method is useful for. I'm going to add a public variable to this script that's going to give me access to it as a property in the inspector. So I've created a variable of type float named speed with an initial value of 5. Again, if you don't really know much about variables, we will be covering that a little bit later. Just understand that this is some amount of speed that currently equals the value 5. Now if I open up Unity, and I look at the cube, I can see now in the inspector that there is a speed variable and its value is 5. I have the ability to change this to whatever I want, and the resultant change will be used as the value of speed in my script. Now, let's pretend I have a much more complex script, and this script has a lot of variables, and a lot of them are exposed here in the inspector. If I ever need to reset or go back to the default values of any component, I can by clicking on this cog icon or gear icon in the right-hand corner and selecting Reset. What I'll notice is that nothing happens. My variable doesn't change. Other variables, things like vectors or such, will be reset to 0 or whatever default value those types have. If I want to define exactly what I want the default values to be on any of these variables, I can do that in the reset method. For instance, if I were to write inside this reset method that speed equals 25f as a default value, then we can see inside Unity that while the value is initially 5, because that's the value we initially give the variable in the script, anytime I were to say reset, the default value would now be placed in there. This is a very simple use of the reset method, but you'll see it a lot in the project, and it's very useful for grabbing references to various game components and other game objects throughout our scene. These are, of course, a very small amount of the total number of built-in methods that Unity provides for us. We couldn't possibly go over every single one of them. Instead, we're just going to focus on these few that we'll see very often. If you want to see all of the built-in methods that Unity makes available to us, feel free to check out the documentation. They're all written about there, and you can learn a lot about all of the different ways that we can utilize Unity without really having to do too much work.